All right, welcome. So you can see that screen and you can get to those also in the chat. So if you're just able to open the 3 links, and so it'd be the teacher site, the agenda, and the idea capture tool. If you're able to go into the idea capture tool, that's that 3rd link, you can just see Matt and I wrote and Emily's already written. So if you could just do those first 4 questions. And then also once you're done, kind of, look around. Some people are from the same district, but, people from across Oregon are here. So just kind of interesting to see who you can connect with. And I'll go back to my screen here and turn off. Well, I'll keep it on here, I guess. All right. And if you even want to go ahead and say hi, we just suggest that you write your name, copy your color font, like copy a word, paste it next to someone else, rewrite your first name maybe, and then just a response if similar connection or just having a chance to reach out to each other. Something we do with students as well, especially if you use Zoom, a really good tool for the breakout rooms. There's pretty limited options. They can just call you to the room, but it might take you a little bit of time to get there. Or 5 groups have the same problem because you forgot to put the link somewhere that you told them to look. That's never happened to me. Today. Okay, well, we have maybe actually a full more minute, but then time is really precious with these webinars, so we'll dive in just a minute.
Again, those of you who are just now joining us, I posted 3 links in the chat. The first is to the teacher site. The second is to the agenda for today. And then the third is to the idea capture tool that we'll use to do some reflection and just checking in with other people who are in the webinar. And so as you are writing in the idea capture tool, maybe scroll up or down to see who else is in with us today.
Great. Okay, just about 20 seconds if you want to try to respond to someone else in this last bit of time, and then we will start with the webinar. Okay, so to get to the heart of it, the goals of the webinar, to give that overview of the unit, I was able to just peek, sounded like this good match. It's what people were expecting. And then we've got a lot of positive feedback on that format where we're gonna go over the whole unit in 1 minute and then take 15 minutes to go over it. And then dive deep into one of the activities. And I think most of the time it's been Desmos teacher activity, and I think that is the plan for tonight as well. So probably more authentically, it's go over the whole unit in 2 minutes, 20 minutes, let you really dive in for 15, 20 minutes into the unit to immerse yourself and get some familiarity. And then one more comment is the idea capture tool is our recommended spot for your question. So if something's just gone wrong, where we think we're sharing a screen and we're not, go ahead and just interrupt. But most questions, please do save, put them in the idea capture tool with Matt and I. we can be monitoring that real time. And in the past, we've even had kind of going in parallel. So people are finding that the chat in Zoom is going to be less monitored. So that is really a chance for you to connect with each other. But so don't put the burning questions there though, because they might get missed with that rapid flow of the chats. Okay, with that, I guess go click on the agenda to share that quickly. But here's a lot of important links. You probably already have them. So again, the overview in 2 minutes, and then a touch on everything that we're doing over 20 minutes, a deep dive for 20 minutes, and then some time for reflection and questions, Q&A. Okay, well then I want to pull up the Patterns Physics teacher site, and distance learning calendar. You can, this is it shown to you, but if you want to make a quick copy, you click it right here, and then you can have it. There's a tutorial customizing it for your own class. Most people have already done this, so I will not say much more unless someone asks a question in the idea capture tool. Okay, so this is again possibly familiar, and Matt and I, we didn't talk about this, but I did pull up the learning targets, and I checking in with the pacing. We kind of predicted this would happen in the summer, and it's just we're not going to get through everything this year, and we need to go at a pace that's the right fit for our students, and that's different period to period, school to school. So it's possible, we're all in different spots, and that's probably a good thing. So we did want to make sure to get to units 5. It's well set up for distance learning, and it's new, right? It's kind of new and interesting. Then unit 6 would come next, electricity, power production, and climate science. Really important unit that we really want to encourage people to get there. And that also, because energy is so important, it always was in unit 3 and 6. Unit 6, power production, assumed that they had already learned some energy. So we do got to put some scaffolding back into 6 to make students successful with it. But the learning targets from unit 3 are already there. And then unit 7, space in the universe, also really well set up for distance learning. Also grabs at some students that might not have been grabbed from the other units. And so that was the natural fit, because there really wasn't a way to modify engineering a shoe for distance learning. And of course, space in the universe already had universal gravity, the force of universal gravity. So force learning targets can find a home there. Okay, so I do want to just focus on unit 5 and save some of those questions for the idea capture tool though. So just to be clear, I did, because it's a resource, oh no, I got too many tabs open. I got every tab I need for the webinar, just so you can see that though. Unit 1, unit 2, I don't know whether we should call these units, I don't know. But third thing we're doing, waves and technology, just to remind ourselves of the performance expectations. And I don't think it's worth reading them to you, but so we got the wave equation, and I'll just summarize: evaluate digital storage, evaluate the validity and reliability of claims in published materials, right? This is, everyone is talking about how do we evaluate materials we're consuming as legitimate. So, it's one that people oftentimes skip, and just want to encourage you that science education is really meant to them to bring that scientific thinking to their whole lives. So we got to practice that, and that's a chance to do it. And then communicate technical information about technological devices using waves. Okay. So let's go back to our unit arc. And in fact, this doesn't have it filled in because we don't want students to see it. So I'm going to scroll down to remind everyone that this is a resource, because I think you're going to use it more than ever. Here is our teacher in-person calendar, which has every single thing here. So again, we experiment with waves. And in fact, maybe I do want to go up to the counter that you're going to use. I'm going to use this left bar because that's what it's there for. So again, we can still do that. How are you hearing me? Even with teleconferencing, I mean, you might want to integrate it right into your Zoom call or Google Meets, or you could still have the phone and have them answer the phone right on the spot. But we like to start with that phenomenon, that question. And then it's making system analysis. We did it in unit 2 with texting and driving. We're going to kind of up the game a little bit. And I just want to hammer it because I'm going to say it 3 or 4 times. Exposure, practice, mastery. There's a technical reading here that they're not meant to understand everything the first time through. And I'll save it till we go back again. Okay, and then once they have some background and they're thinking about how cell phone communication works, we need to take a dive into wave behavior, that physics wave equation. And so that they have the experience to understand that as it's described in the performance expectation. And then we have our first crack at how technological devices uses wave behavior. We have that looking at ultrasound medical imaging. And then we're that evaluate published sources. So the question that frames it for us is, do cell phones cause cancer? And then we end with them finishing that project of doing most of the good stuff that a cell phone does to enable a call or a text message to be sent from one device to the other. Okay, so that was the unit in 2 minutes-ish. So now we're going to go back and take 20 minutes. So a little bit more, but probably not everything you need, but enough to start the conversation. Okay, so I'm going to close that because I don't need it anymore. Okay, system analysis. I just wanted to open on this just to say it one more time. This is the exposure part of exposure practice mastery. Some people who kind of start the unit without seeing what the end of the unit is, try to do a big vocab list and want to quiz them. We're 4 weeks from now, we want them to be able to do all of that. So we want to teach them that you can read something and not get everything, and you might have to go learn and come back and reread it. So let that process happen. They don't have to have it all figured out on day 1. Okay, and just to give the glimpse, this is the glimpse. So system analysis, if you've already done it in person, you know this, and if not, this should also look like unit 2, texting and driving. So we break up a cell phone call, and it starts with talking, and I'll even to really kind of an answer key is right here, talk, vocal cords vibrate, producing sound waves. That's what we're looking for on day 1. 2, phone does its thing, turns sound digital and sends it to the network. That's what we want day 1. They are going to come back and by the end use a lot of technical vocabulary, those kind of things to be precise, but we want 4 weeks to develop it. So again, keep it simple to start. Keep it simple. All right. So to zoom back up, that is the how are you hearing me? That's what we want. The homework is excellent. These videos do a pretty good job too. All right. And then from here, I'll hand it over to Matt.
Yes. So the next activity, if you're familiar with patterns approach, we've used a simulation to simulate waves in the past. And so we're going to use the same PhET simulation for students this time around. And we're going to be looking a little bit at an activity that we did in person, which was looking at, we call it tinkering with a wave. So the first activity there is an activity Desmos builder. And we use some tools from Desmos that we couldn't do in person. And so now I actually prefer this method of delivery more than in person. And so it's just kind of one of those iterations that CDL has helped us. So the idea for this is that students are building common vocabulary, and later, after you get a chance to play with it, we can show you some student examples of how students have built this vocabulary, but they're building it by playing on this example. So students play with the amplitude, play with the wavelength, and they come up with their own definition. What do you think the wavelength means? What do you think the amplitude means? And then I had students sharing that out and looking at each other's responses using the Desmos, what is it called? The screenshot tool. So you can look at lots of students' examples there, but they're generating these technical words through play. We're gonna not go too much deeper into this tinkering with the waves, because at the end of the activity, or at the end of our overview, that's the activity that you're going to do the deep dive into. The next activity that Bradford has up there, just kind of zooming back out, is in that first activity with tinkering with the waves, students were playing around with the different wave properties. So they learned of what amplitude was, what frequency and wavelength were, a little bit of how to actually take data on what wavelength is, and a little bit of training on how to take data on the wave velocity. So they are well prepared to come into this lab because they've been playing with the simulation. So they start with the simulation, and this is just a GIF that is in the Desmos activity where students are going to take data on the wave simulation. And then Bradford, can you click next? Maybe, yeah. So this is set up very similarly to other Desmos graphs that they've done. They're going to put the data into the data table for frequency and wavelength. And then when they go to the next screen, they'll have the graph, and as they've done on other activities, do this. One added complexity to this is that there is another research question that they look at, which is how does the frequency affect the wave velocity, which Bradford, you don't necessarily need to show, but it's on the next slides as you are clicking through that. Also associated with this is a data discussion, just in the same format as the other data discussions that students have seen. So this one's formatted a little bit differently, as there's two graphs that they're going to look at. So there's a third slide where they actually end up comparing the two graphs and looking at what they notice versus the similarities and differences. And Bradford highlighted that as where you can find a class copy of it and go from there. And then we just also added a kind of a digital practice with waves that's there.
Excellent. And to keep the pace going, then now that they understand waves and wave behavior, we want to build and apply that knowledge. So we're going to look at medical imaging. So that's the, I think it's an Australian soccer club. We got those videos here so they can watch it. If lots of times showing a video over Zoom and stuff like that doesn't work. So there's that video right there. Want to just show that there's multiple levels. So, depending on what the appropriate challenge is, remember they're in the role of doing what an ultrasound does. So they get some background on the patient, the background on the medical imager, they get the raw sonogram, or actually, I guess this is just the raw data. And then they make from that a sonogram, that image, and of course, then evaluate if, in this case, it's a patellar tendon. We used to do the kidney stone, right? But that didn't connect with students as much. So this has been changed for a couple of years. So in any case, there's lots of those questions, but some people were saying that was just too open-ended for students. So again, on the calendar, you saw a level 1 support. So you can just see that here is a level 1 support where it fills in some of that need for students. Now, again, I kind of skipped over it, so I'll just only quickly return to it because I just want to show they have to code the sonogram, and we have 3 layers that each have their custom made tutorial. So this is the lowest one where students have to do the most. The tutorial walks them through every step. However, there are times when that's still just not the right fit. But a lot of people do, now that the tutorials really walk them through every step. Here's one level up. It has just a little bit more completed. And then level 2, because they do the left knee, and in 0, they're told to just recreate it for the right knee. But here, a lot of it is done for them. And there's a lot of, you can copy and paste once you make it the left knee, you can copy and paste to the right knee. To zoom back out, I just want to show there's multiple levels of support. 0, which is embedded right in the original doc, level 1, level 2. So you can decide whether that's class-wide or maybe it's smaller group precision about matching the right levels. So big goal for this unit is computational thinking. And
in the next activity, students are going to look a little bit deeper into that idea of, do cell phones cause cancer? And that is specifically targeting an NGSS standard. So it's also super important. There's lots of skills for us to be able to show students how to evaluate sources, how to evaluate them if they are reliable. And so we actually have 2 versions of this that we created. If you have been using GoFormative, I've found GoFormative to be a very useful resource while doing CDL, because I can give students feedback and track kind of where they are with the view responses and the assign. In this document, what students are going to do is they're going to get some background knowledge on like different things, different technical terms. And in the Show Your Work, Bradford, if you could click on that Show Your Work. It is an excerpt from cancer.gov. And so this is different technical writing, but it's really made for lay people. So that we took from cancer.gov and put into here. So what students will be doing is they'll be looking at just trying to pull some key information out on there. So some claims about ionizing radiation being harmful and non-ionizing radiation being safe. We also, and yeah, we're planning on having them kind of highlight as they read through what the 4 claims that the author was making when they were doing this. So idea of like highlighting in those 4 different colors of where those different claims were. Then if you continue on down, Bradford, in the activity, they're going to look at 2 articles. One of them is an article from Wired magazine that's, I won't go into super detail, but it goes over some studies that are discussing how cell phones probably do not cause cancer. And then if you scroll down a little, or actually as they go through that, they are looking at what type of resource it is, different cues that help us kind of determine how accurate or credible the author is. And then on the second article, Article B, it's pseudoscience. It's fake. They are selling something. So when you click on that link there for background info for Project Protect Pro, it's a website that is selling frequency blockers for cell phones, and it is truly pseudoscience that they are selling. So we're trying to get students to compare and contrast a more credible source to a source that is trying to sell something. And then finally, at the very bottom, we give them one last article to look at. And the last article, if you've seen this activity before, is one that looks very sciencey. Like it is referencing University of Washington. It references a foundation, but it is truly bogus. And so we explicitly call that out as pseudoscience. And so it looks good, but it's not. So students are challenged to find cues in there that are kind of going to indicate whether it's a good source or not. Then Bradford, if you could go back to there, yeah. We also added a video there. It says like the truth about 5G. When I started this unit a couple of weeks ago, my students the most common question is like, what about 5G? What is 5G? there were lots of questions about that. And so that is actually a great video that talks about the basics of what 5G is, and then also goes through some of the conspiracy theories that are associated with it, and knocks those off. So
great. And then to round out the unit is them looking at how to do most of the good stuff of a cell phone communication. And so we got our portfolio, just some minor changes now with them doing it over the internet instead of in person, which actually in some ways makes it more authentic. It eliminates them just sort of talking to each other. And yep, so that was the big thing. Wanted to show that, of course, and there's a lot of resources here. And I want to jump back to here and say this, and I don't know, we contemplated putting that. I just want to show the teacher calendar. Sometimes if you want more for that, if you're like, oh, I'm not sure. We didn't want to, whoops, oh, sorry, you got to, it's a web page within a web page. So I just clicked into it. So it brought me back to the top. A lot of scrolling there. Sorry about that. I do want to just point out the multiple levels of support within the portfolio. So again, this is like judicious. The tutorials there are helpful, but again, level 1 or level 2 might be more appropriate. So you can decide that appropriate level, but this is an engineering challenge that it's very different than the rest of the unit and the course, right? So it is one that it's going to take a little bit of time though. So, I mean, a couple days, 2-3 days. And so, decide if you have the time to do it, but know that there are multiple levels depending on what's the right fit for your students. And I will say that level 2, it's almost could be done asynchronously. So it does bring them through step by step. Okay. So that was the whole unit in 20 minutes. So, and of course, there's all the quizzes and stuff that for people that want it. And I will just point out, now they go back and reread, how are you hearing me? That's the time we now want them really understanding all of the technical terminology that is in there. Okay, with that, I'll just pop out to the agenda to let us kind of think where we are at that level. So we just did the overview of the unit, and now looking at taking the deeper dive into the Tinkering Wave. So if you can click on that link, Tinkering with a Wave, you'll go into the activity. And we were going to put you into breakout rooms, and just in the past, work with it. I would just say some of the feedback we've gotten, people appreciate talk. This is also a time to connect and talk about Unit 5 more generally, but we have gotten the feedback that sometimes people want to make their way a little bit through the student activity before you have a general conversation. So in your group, give it a shot. So that would be this activity right here. You'll join it. Maybe, you got 20 minutes. So, maybe 10 full minutes on the activity and then let it go free ranging. I do want to point out in the idea capture tool, you can still be in contact, asking questions. I have so many things open, I can't find the idea capture tool, but maybe like you, I'm just going to go to the agenda and refind it.
Yeah, we started answering some of the questions in the idea capture tool. So remember that is linked. I also just linked the activity that Bradford's talking about in the chat. So if you can't find that somewhere else, that's linked in the chat there. And when you get in that, you're going to see it. You're going to be obviously seeing it from the student side. And then what we'll do is when you come back, we can show you, my students have been through this activity, so I'll show you some of the results of what students show and do.
Yeah, this is us. Okay, so we'll start up the breakout rooms. I'm going to stop screen sharing. Whoops. Okay, create. So do put, try to give it a shot. Talk about, make it useful for you though. and put questions in the idea capture tool. You can also flag Matt or myself to join your group. So we'll try to pop in. All right. If not, see you in about 19 minutes. So actually, so they're supposed to do the reflection questions 5 and 6.
Yeah, I was going to show student examples and then do that. People should be coming back in just a couple seconds here. All right, we hope that time was useful for you to just get a deep dive into one of the activities that students will be doing. What we wanted to do kind of for the rest of the last 10 minutes that we have, I want to show you some student examples that we ran live with students this year. Then we'll do some reflection on questions 5 and 6 on the idea capture tool, just to try to have a little bit of space to reflect and answer questions from the parking lot, many of which, or all of which so far we have answered. So if you have more questions, those can go on that parking lot there. I did just want to show you some student responses, and somebody asked in the parking lot, how do you show student responses there? So this is the overlay. It's not a very nice way to do it, but you just did this activity. And I was very impressed with students oftentimes being able to come up with the correct definition of wavelength and amplitude by just playing around with that. And so what I like to do, one thing is you can take a snapshot of their responses. So in Desmos Teacher, I'm in the teacher mode here. So I can see whatever all the students are doing. And so this person said, the wavelength is the length of one wave. So what I can do if I wanted to share that, there's a little camera there. I click that and it says screenshot captured. And I prepared a few for us that you can make categories. And so when you take the snapshot, it shows up on the left side, and you can take those and drag them in. And then if you want to present those, you can hit present and it ask a question or do a follow-up there. So, and you can make multiple of those screenshots so that those are prepared. Oftentimes we do that for like the next day, not live, but that next day. The other thing that I wanted to show, which was one reason I think that this activity went a little bit better for me actually online than it has in person in the past, is a lot of times in the past students for slide 7 would get incorrect data, or their assumptions would be too strong for like what they expect to happen. So it was one thing I was doing was just monitoring, jumping in and out of breakout rooms, and you can still see a couple of my students didn't change that, but it just gave me a little bit of feedback when they went on from slide 7 to slide 8, and I can jump in and see that kind of interrupt those. So this person clearly wasn't measuring wavelength correctly. So that was one really positive tool that I used this year when I was doing tinkering with the wave. With that, what we're going to do, we have about 7 minutes left here, and we're going to really use the rest of this time for reflections. We'll spend a little bit of time in the idea capture tool, answering some questions, putting some questions in the parking lot, and some of those questions, if they come up in the parking lot, we might be able to speak to either written or over Zoom. But if you could head back to the idea capture tool and find where you wrote your name, and have you answer those two reflection questions, which were just reflect on we left a space there for on number 5 to reflect on the leveling of scaffolding that you might need to do for your students. And then number 6 is just a one sentence summary or takeaway from the webinar. So give you a moment to jump over to that. And we'll respond to those.
And we have been able to respond to all of the questions in the idea capture tool. So know that they get answered. There were just even a couple that just got put up that we haven't gotten to, but we'll do that now. We're getting close to the end too. And so want to kind of open up all the channels. So if there's a question you want to just ask, if that's the better fit, I think we're getting to everything in the idea capture tool. I'm hoping to scan the reflections here too to see if there's something good. But did anyone have, yeah, just any, welcome comments and questions, experiences that you want to share that might be, yeah, just helpful to the people here?
I have a question for you guys. You guys already did the this unit. Is that correct? You've completed it already this year?
No, we're in the middle of it right now.
Okay. Do
no.
you expect so the send a text message to be about the same as it was, where they're doing like, either amplitude or frequency modulation with either a sound or a light wave, and having them kind of problem solve and how they're going to send a sound wave through?
Yeah.
You know what I mean? It is kind of more authentic, but do you plan on them doing some problem solving in that regard?
Yes. So I'll say yes. And that, yep. And so that's, it's a real, and like, I'm hearing it from everyone. It's hard to get students to talk, right? Teenagers, it's hard anytime, but in Zoom, when they have even less comfort with each other. And so that's a real concern. Now, sometimes, putting the challenge that they're kind of into, and remember their slides, we really want to make sure you know that teacher calendar is there. You will want to show the day they're figuring that out. The slides allow you to scaffold it to have them be successful. So you could walk them through step by step, but we want to give them the least help that will allow them to be successful. Also, I just wanted to throw this out there because I saw one comment about the medical imaging. You know, we did that last year in the remote learning. It was the best thing we did in remote learning. So it connected with students, and that was pretty asynchronous even with that. So just want to, you know, someone said a deeper dive in that. Clearly there's not time to do the deeper dive during the webinar, but I just want to say, like, students did it asynchronously, almost like, you know, not give, you know, just being given what was there for the most part. So I do want you to know that there are supports to do that. Sorry, we didn't have enough time. You know, sometimes there is this idea, do we want 3 hours for this? And then of course we would do that. But that's, you know, it's all based on, like, you know, do people have 3 hours to give up for that? So just something to think about. And we toyed with this last year, just kind of talking about it, having some, it was kind of our honors extension project. So we didn't have the whole class do it, but it got students to talk. And that was last year. And that wasn't necessarily in person talking. They would write to each other in the shared Google document. So yeah, it is, you know, it's a really good activity, but I want to acknowledge that if students aren't going to communicate with each other, that might not be the right fit, but it might be the thing that gets them to be more connected. Yeah. Okay, we're at 5 o'clock. Matt and I, you know, we always find that there's some questions that people just, you know, it's not the right fit to ask it in the middle of the webinar. So we'll hang out here, but also just to have some closure, if people are willing to unmute and just maybe turn up, let's stop this. Yeah, I don't know if we are screen sharing or not. You know, just that gallery view, I have that on. We'll do a countdown, and if you're just willing to say bye, we'll hang out for a couple minutes. So if you got another question, stay on, but otherwise we'll sign off for today. So 3, 2, 1. Bye.
Bye.
Bye, everyone.
Thanks.
Thank you.
Bye.
This is great. Thanks,
Thank you,
guys.
Bradford. Appreciate it.
Bye.
Okay, we